Have you ever really stopped to think about what happens when you send a message to an AI? You type something simple, maybe just hi. You hit send, and almost instantly a reply just appears. It feels totally seamless, right? Almost like magic. But behind that incredibly simple exchange, there's this huge, complex journey happening. So today, we're going to follow that message step by step as it travels through the entire OpenClaw architecture. It's going to be fun. So picture this. You type hello, you press send, and in that tiny little gap, that split second before you see those three little dots that mean it's typing, a whole whirlwind of activity just kicks off. We totally take it for granted, but what is actually going on in there? What's happening under the hood? And here is the craziest part of this whole thing. It really is an epic journey, but the actual AI, the large language model you think you're talking to directly, yeah, it's one of the very last things in the chain to even know your message exists. The real magic isn't just the AI itself, but the incredible, intelligent system that's built around it. Okay, so let's start the journey. And you'll see it doesn't begin with the AI. It starts way, way before that, with the system's own foundation getting itself ready for action. So this right here, this slide gets to the heart of what OpenClaw really is. It's not a chatbot first and foremost, it's a gateway. Think of it like the air traffic control tower for the entire system. It's this central hub, this control plane that's managing everything. User sessions, communication channels, you name it, and all of this happens before any AI gets involved. So before your hello can even be heard, this gateway has to go through a whole startup checklist. It's checking the network, it's loading its main configuration file, it's setting up all the user accounts from places like WhatsApp, and it starts listening on all those channels. You gotta realize, without this solid foundation running perfectly, none of the cool AI stuff we see on the surface could even happen. All right, the gateway is up, it's running, and it's listening. You've sent your message. So what happens the moment it hits the system's front door? Okay, so your hello has arrived, but it doesn't go straight to the AI. Nope, not even close. Its very first stop is something called the ingestion layer. You can think of it like a digital bouncer and a master translator all rolled into one. This is where all the chaos of the outside world gets sorted out. First, the system filters out any noise, like if you accidentally sent the same message twice. Then, it checks your permissions. Are you even allowed to talk to it? If you sent an image along with your hello, it gets downloaded. And finally, and this is so important, it takes your message, no matter if it came from WhatsApp or somewhere else, and it converts it into a standard, clean format that the rest of the system can actually understand. Okay, so now our message is clean, it's authenticated, and it's standardized. It's officially inside the house. But where does it go now? This is where the real intelligence of the architecture, not the AI, starts to shine. See, the system doesn't just send everything to one giant brain. First, it reloads its latest set of rules. Then it figures out the context. Is this a one-on-one chat, or are you in a group chat where you had to @mention the bot? Then it basically acts like an old-school switchboard operator, routing your message to the exact specialized agent that's meant to handle it. And maybe most importantly, it creates a unique key that links this brand new message to your entire past conversation. Let's just pause on that for a second. Your simple hello has been deduplicated, authenticated, standardized, routed to a specific agent, and linked to your chat history. And the large language model still hasn't been called. The amount of prep work going on here is it's incredible. We're now moving into the final prep phase. And honestly, the best analogy is a master chef doing their mise en place. Meticulously getting every single ingredient chopped and ready before they even think about turning on the heat. This is all the backstage work. A private, temporary little folder is created just for this one interaction. Any pictures or links you sent are analyzed and turned into text descriptions. The entire relevant conversation history gets loaded up. The system also checks if you included any special commands like /reset. And what's really cool is some super simple commands can get handled right here without ever needing to bother the AI at all. All right, the stage is set. All the ingredients are prepped. The full context is loaded. After all of that careful, meticulous preparation, we are finally ready to bring in the AI. And you have to understand, when OpenClaw calls the AI, it doesn't just send your hello message. Oh no, it sends everything. This is what prompt engineering on steroids looks like. It injects all the documentation for its tools, project notes, personality files, summaries of what it's learned, the entire conversation history, literally everything it could possibly need to have the maximum amount of context. But as the source material itself points out, this is a bit of a double-edged sword. Giving the model all this information is incredibly powerful, but it also uses up a ton of expensive tokens. And sometimes you can actually confuse the model by giving it too much information, diluting its focus. It's a classic engineering trade-off, really. Perfect context versus cost and efficiency. And so, with all that prep work done and all that context assembled, now the system finally makes the call to the large language model. It uses a toolkit called the Pi SDK to do this, which is basically the specialized connection that lets the system and the AI talk to each other. And this is what kicks off the agent loop. It's a cycle, right? The AI thinks and it generates some text. Now, that text could be your final reply, or it could be a command for it to use one of its tools, like read this file. If it uses a tool, the result of that action gets fed right back into the conversation, and the AI thinks again. This little loop of thought, action, and observation just keeps going until your request is completely finished. And you know that typing effect you see on the screen? That's not fake. As the agent loop is running and the model is generating its response, the system is streaming it back to you in real time, word by word. You are literally watching the AI think and build its reply as it happens. So our little hello message has made it all the way through the system, and we've gotten our reply back. Let's just pull back for a second and look at the big picture here, because the real genius of OpenClaw isn't just the AI model, it's the entire system we just walked through. So when you boil it all down, what did we learn? Well, first, OpenClaw is a master runtime assembler. For every single message you send, its main job is to build this perfect, temporary little world full of context. Second, it does all the dirty work, all the authentication, file management, error handling, all the stuff the AI shouldn't have to worry about. Third, it's a form of extreme prompt engineering. It translates its entire environment into a language the model can understand. And finally, and this is probably the biggest takeaway, its true identity is a gateway. It's a control plane, and the AI is just one very powerful component that it chooses to use. And that kind of leaves us with this big, fascinating question to think about. As we keep building more powerful AI, is the real frontier of progress in just making bigger and bigger models? Or is it in designing these smarter, more sophisticated systems like this one? The architectures that get the world ready for the model and get the model ready for the world?